Car spark plugs. 1. Ignition source. Spark plugs create the electric spark that ignites the air-fuel mixture inside the engine's combustion chamber. 2. 1 per cylinder. Most gasoline engines use 1 spark plug per cylinder, though some high-performance engines use 2. 3. Powered by high voltage. Spark plugs receive up to 20,000 to 40,000 volts from the ignition coil to produce a spark. 4. Critical for engine starting. Without properly working spark plugs, an engine may be hard to start or may not start at all. 5. Different heat ranges. Spark plugs are designed with specific heat ranges to prevent overheating or carbon fouling. 6. Materials affect lifespan. Common types include copper, platinum, iridium, with iridium lasting the longest, often 100,000 kilometers plus. 7. Affect fuel efficiency. Worn or dirty spark plugs can cause incomplete combustion, reducing fuel economy and power. 8. Gap size matters. The space between the center and ground electrode, spark gap, must be correctly set for proper ignition. 9. Wear over time. Electrodes slowly erode with use, which weakens the spark and causes misfires. 10. Warning signs of failure. Symptoms of bad spark plugs include rough idle, engine misfires, poor acceleration, and increased fuel consumption. Ignition coils. 1. Voltage booster. Ignition coils convert the car battery's 12 volts into 20,000 to 50,000 volts needed to fire the spark plugs. 2. Essential for combustion. Without a functioning ignition coil, the spark plug cannot ignite the air-fuel mixture. 3. 1 coil per cylinder. Modern cars. Most modern vehicles use coil-on-plug (COP) systems, with 1 ignition coil mounted directly on each spark plug. 4. Older systems used fewer coils. Older cars often used 1 coil with a distributor or coil packs serving multiple cylinders. 5. Triggered electronically. Ignition coils are controlled by the engine control unit, ECU, which times the spark precisely. 6. Heat and vibration sensitive. Coils operate in high heat environments and can fail due to heat stress, moisture, or vibration. 7. Misfires are a common symptom. A failing ignition coil can cause engine misfires, rough idling, loss of power, or poor fuel economy. 8. Check engine light indicator. Bad ignition coils often trigger a check engine light with misfire-related trouble codes, e.g., P0301. 9. Designed for fast switching. Ignition coils rapidly charge and discharge thousands of times per minute, even at low engine speeds. 10. Performance upgrades exist. High-performance ignition coils can provide stronger, more consistent sparks, especially in turbocharged or high RPM engines. Distributors, older vehicles. 1. Controls spark timing. The distributor directs high-voltage electricity from the ignition coil to the correct spark plug at the right time. 2. Used in older gasoline engines. Distributors were common in cars before the late 1990s and are rarely used in modern vehicles. 3. Driven by the engine. The distributor is mechanically driven by the camshaft or crankshaft, keeping spark timing synchronized with engine rotation. 4. Contains a rotor and cap. Inside the distributor, a rotor spins and sends voltage to terminals in the distributor cap, each connected to a spark plug wire. 5. Works with a single ignition coil. Older systems typically used 1 ignition coil to supply power to all cylinders. 6. Mechanical and vacuum advance. Many distributors use centrifugal, mechanical, advance and vacuum advance systems to adjust ignition timing based on engine speed and load. 7. Requires regular maintenance. Distributor caps, rotors, and points, in very old systems, wear out and need periodic replacement. 8. Sensitive to moisture. Water or humidity inside the distributor cap can cause misfires, hard starting, or stalling. 9. Points versus electronic ignition. Very old distributors used contact points, while newer versions used electronic ignition modules for improved reliability. 10. Replaced by modern systems. Distributors were phased out in favor of coil packs and coil-on-plug systems, which offer more precise timing and less maintenance. Ignition wires, spark plug wires. 1. Carry high voltage. Ignition wires transmit 20,000 to 50,000 volts from the ignition coil or distributor to the spark plugs. 2. Used mainly in older vehicles. They are common in cars with distributors or coil packs and are mostly eliminated in modern coil-on-plug systems. 3. Built for insulation. Ignition wires use thick silicone or rubber insulation to prevent voltage leaks and electrical interference. 4. Resistance is intentional. Most ignition wires are resistor type, designed to reduce radio and electronic interference. 5. Length matters. Each wire is a specific length to ensure correct routing and proper firing order. 6. Heat exposure causes failure. Engine heat can crack insulation over time, leading to spark loss or arcing. 7. Symptoms of bad wires. Worn ignition wires can cause misfires, rough idle, hesitation, poor fuel economy, and engine shaking. 8. Visible arcing test. At night or in low light, damaged wires may show visible sparks leaking to metal engine parts. 9. Routine replacement item. Ignition wires typically need replacement every 50,000 to 100,000 kilometers, depending on quality and conditions. 10. Proper routing is critical. Incorrectly routed wires can cause cross-firing between cylinders and engine performance issues. Radiator. 1. Controls engine temperature. The radiator removes excess heat from the engine to prevent overheating. 2. Part of the cooling system. It works with the water pump, thermostat, coolant, hoses, and cooling fan. 3. Uses coolant, not just water. Radiators circulate a coolant, antifreeze mixture that resists freezing, boiling, and corrosion. 4. Heat exchange design. Radiators use thin tubes and fins to transfer heat from hot coolant to outside air efficiently. 5. Airflow is essential. Cooling occurs as air flows through the radiator while driving or via an electric, mechanical fan. 6. Usually mounted at the front. Radiators are positioned behind the grille to receive maximum airflow. 7. Made from aluminum or copper. Modern radiators are typically aluminum, while older ones often used copper and brass. 8. Leaks cause overheating. Cracks, damaged hoses, or worn seals can lead to coolant leaks and engine overheating. 9. Radiator cap regulates pressure. The radiator cap maintains system pressure, raising the coolant's boiling point. 10. Clogging reduces efficiency. Internal scale buildup or external debris can restrict coolant flow and airflow, reducing cooling performance. Radiator fan. 1. Helps control engine temperature. The radiator fan pulls or pushes air through the radiator to cool the engine when natural airflow is not enough. 2. Works mostly at low speeds. Radiator fans are most active during idling, stop-and-go traffic, or when the vehicle is not moving fast. 3. Can be electric or mechanical. Older vehicles often use belt-driven mechanical fans, while most modern cars use electric radiator fans. 4. Controlled by sensors. Electric radiator fans are switched on and off by temperature sensors or the engine control unit, ECU. 5. Turns on automatically. The fan activates when coolant temperature reaches a set point and shuts off once the engine cools down. 6. Also cools the air conditioning system. Radiator fans help cool the AC condenser, especially when the AC is running at low speeds. 7. Multiple fans may be used. Some vehicles use dual radiator fans for improved cooling and redundancy. 8. Fan failure causes overheating. A bad motor, relay, fuse, or sensor can prevent the fan from running and lead to engine overheating. 9. Can run after engine shutdown. Electric fans may continue running briefly after the engine is turned off to reduce heat soak. 10. Efficiency affects fuel economy. Electric radiator fans are more efficient than mechanical fans and help improve fuel economy.